Okay, so we'll start building our processing. So first is entity. So red part, location is parts intake. Okay. Now we're going to batch up. Remember the batch size for red is 4. So we accumulate accum 4, and then the red part goes to knitting. Okay, so it goes to knitting. All right. So now we'll repeat that for blue part. Okay, parts intake. So now we're going to accum 6, right? And then the accumulated 6 parts will go to knitting. Okay. Now we are at knitting. Now remember, knitting, the time is same. Oh, time is not the same. Okay, so we have to define time is not the same for blue and red. So we have to define those operations individually. So blue part location is knitting, right? And the wait time, okay, so wait is normal, blue is 8 and 6, okay. So normal 8 comma 1 second, and after knitting it goes to buffer spring. So blue goes to buffer spring. Now red part after knitting spends, I'm going to copy paste that, 6 comma 1, and then the red part goes to buffer spring. Okay. Next, from buffer spring, okay, so now spring takes the same amount of time for both. So we don't have to route them individually. Okay, we can simply say all parts, all entities from buffer spring, okay, output to output entity is all parts, destination is spring. Okay, now we have a move logic here, and the move logic is we need handler, and the time is normal 10 comma 2. Okay, normal 10 comma 2. Okay, so the move logic here is move with handler for normal 10 comma 2 seconds, then free. So handler is freed after that. Okay, so now we have all entities, okay, at spring. Okay, and we're going to wait how much at spring? We're going to wait 9 comma 1. So 9,1 seconds. And then, okay, so that's our spring. Then all of that goes to buffer resistor. So it's all going to buffer resistor. Okay. Now from resistor, so from buffer it's going to go to resistor, and then we're going to branch off. Okay, so we have to make a distinction between red and blue part. So we have to define these individually. So we say, all right, we have blue part from buffer resistor. Okay, do we have any move logic here for that? Okay, from buffer resistor, so move is, we don't need handler, 8 comma 2. So buffer resistor, okay, so blue part will go to buffer diode. And it will be move for n 8 comma 2 seconds. Okay, so that's going to diode, and then we have red part. Okay, red part from buffer resistor, I'm sorry, resistor. No, I should, okay, so I made a mistake here. So now blue part from location, so okay, so we have spring to buffer resistor. From buffer resistor, it should go to, blue part should go to resistor. Okay, I made a mistake here. So buffer resistor, okay, there is no move logic there. And then blue part will be, okay, so you are at resistor, and the resistor time is 6 comma 1. So wait normal 6 comma 1 second. Okay, for blue. Okay, and then the output is blue part will go to buffer LED buffer diode. So blue part will go to buffer diode. Okay, and then red part will go from buffer resistor to resistor. Okay, was there a move logic for that? Okay, so there is no move logic for buffer. Well, no, there is buffer resistor to resistor is n 8 comma 2. So did I put that there for blue part buffer? Okay, so I need move for n 8 comma 2 seconds, and I need that here as well. Red part from buffer resistor to resistor, and then red part from resistor, you're going to spend, the red part of resistor is 12 comma 1. So I'll copy that and paste it here. 12 comma 1. Now this is going to go to LED. So the red part is going to buffer LED. Okay. So now we have blue part in buffer diode. So we need to take care of that. Blue part buffer diode. Okay. To blue part to diode. And for that, okay, buffer diode to diode. You don't need handler, but you need time. So move for n 8 comma 2 seconds, and then okay. So now blue part a diode, and how much time? Blue part a diode is 17 comma 1. So there it is. So wait 17 comma 1 seconds, and then the blue part will from there go to buffer LED. Alright. Now at LED, so we have the same time, so we don't need to separate blue and red. So we have buffer LED, so we now go to all entities from buffer LED, and all of them go to LED, and the move logic is move for n 8 comma 2 seconds. No handler necessary. And then here again we have all at LED, and the processing time is 8 comma 1 seconds. Okay, and then from there they all go to buffer test. Okay, then okay, so buffer test. Okay, to test, now we need handler to go to test, and testing takes the same amount of time. Alright, so we can now say all at buffer test, okay, and all is going to test. Okay, so the move logic, I'll type it here, move with handler for n 10 comma 2 then 10 comma 2, then free. Okay, so that takes us to the test station. All right. Now at test station, okay, at the end of test, we're going to have to figure out how many are defective or how many are not defective. And that is, how many are defective for blue follows binomial distribution, but it's 6 is the batch size for blue and 4 is the batch size for red. So you're going to have to separate them. You have to define the number of defectives for blue and red separately. So we need to look at the test station individually for red and then the blue part. Okay, so we'll continue that in the next video.